All right, so this is an ice chart question, another example, ice. And I've started this question already, but I'll just reread it here. Phosphorus pentachloride decomposes into phosphorus trichloride, that's this one, and chlorine gas right here. So we're starting off with 0.5 moles of pure phosphorus pentachloride. That's what we're starting with. And it's placed in a 2-liter bottle. So if we only have this to start with, we would have nothing of the other until equilibrium, right? Or until it starts to decompose. So we're dealing with concentrations on ice charts always. So first of all, let's go 0.5 moles divided by 2 liters, and that's where we get this number right here, 0.25 moles per liter. So that's our concentration of PCl5. So let's put that in here, 0.25. And we start off with 0 and 0 here. The other compounds here are not mentioned at all. It just says we start with this. So we can assume that we have 0 at the very beginning of all the other things. All right? So we want to find out what the equilibrium concentrations are. So we're looking for this bottom row. So how we do this is we understand that we're going to have to use the Keq, and sometimes you'll see this as a Kc. So we always call it a Keq. And so what you want to do is you want to say, all right, this is going to change, right? As this reaction begins and goes to equilibrium, this amount is going to decompose and it's going to become this stuff over here. So this is going to go down in concentration while these two go up. Okay, this is going to go down and those two are going to go up. By how much is unknown, but what we do know is the relation between the moles of the substances in the equation. So notice that they're all at 1 to 1 to 1 mole ratio. And so that is down by one unknown amount. This is going to go up by one unknown amount and up by one unknown amount. Okay? Because we have no idea what the equilibrium concentrations are, we have to form representations or expressions of each. So this PCl5, we know it started off as 0.25 molar, and it's going to go down by some unknown amount. This is started at 0, and it's going to go up by some unknown amount, so that's just going to be x and x over here. Okay? So now we use the information in the chart here, and we use also our Keq expression. So now we go to Keq, and we write that. So we look back over here, and we're going to have the concentration of Cl2 times the concentration of PCl3. And we always go with the substances that are on the right side. They're always on the top. Always. Because of the nature of this number here, right? That's where this number comes from when it's set up like this. So we divide by the concentration of the reactants, and here's just 1. PCl5. Right? Okay. The other thing you want to double check, and it's hard to see here, but make sure that these are all gases. If there are any solids or liquids or something like that, they wouldn't be involved in the chart, and they wouldn't be involved in the Keq expression. Only gases. Okay? So for most of the questions, everything will be gas. For some, you may have a solid reacting with a gas, and so on. So you have to just watch that. So once you get to this point, now we can substitute everything in. At equilibrium, this is the Keq constant. At equilibrium, the expression for PCl5, the expression for PCl3, and the expression for Cl2. So we just plug everything in. And that looks like this. 0.0211 equals x times x all over 0.25 minus x. Okay? And this is just to the power of 1, so it looks like that. Okay? So as we kind of follow through with the math, now comes the math time where you solve for the x. And if we look ahead here, we're going to have an x squared, and we're going to have an x term, and we're going to have a constant term. So you're going to have to think about the quadratic formula or factoring. So this is a good question to do with kind of a little bit of an upper level of math here. So let's just do this, solve for x here, or at least multiply out and get these x terms together. Okay, so when you multiply this out, multiply these out over here, this is x squared, giving over to one side. This is definitely a quadratic, okay, expression. See, there's x squared and x and then no x. And we're going to bring everything over to one side and equal 0 because we're going to find the roots of this quadratic. A couple different ways you could do that. You could put this into a graphing calculator, actually, and find the x-intercepts, right? If you remember from math. In Chem 30, there's a little bit of math required for Chem 30 for a reason, because of this right here, right? If you've never done this before, this is going to be a struggle, but there's a lot of math aspect to chemistry when you're talking about stoichiometry and you're talking about this kind of thing. So if this is unknown to you, then you have to listen carefully to this one. So if you graph this, and you could find the x-intercepts, which would represent the roots of the equation. That's one way. The other thing you could do is use the quadratic formula. And you remember that little song? X equals negative b plus or minus root b squared minus 4ac all over 2a. Very good. Wow, that's really good. You guys remember that? Okay. So you remember this one. All you need to do is identify a, which would be the coefficient on the squared. So that's 1. Identify b, which is the coefficient on the x term. That's this one, 0.0211. And identify the c, which is the constant, and you have to include the signs as well. So, not necessarily the most, simple thing in the world to actually do this, but you do this on your calculator, and it does most of the work for you. Okay? So you plug it in there, you're going to get two different answers. I think one of them might be, one of them definitely will either be a negative answer, or it will be an answer that's bigger than 0.25. So that's no good either, right? Because you can't go less than 0.25. You can't go less than 0. So there's going to be two answers maybe, and one you'll be able to reject. So let's just calculate that. All right, so when you plug these values into the quadratic formula, you should get these two numbers. Now, I graphed it over here as well on Desmos, and we see that we have the same two numbers. And remember, when you graph it, you calculate the intercepts, the x-intercepts, and those will be your roots. I also did it on the calculator here. I haven't calculated the intercepts, but you can see that you can calculate this intercept and this intercept. Okay? And so anyway, so these are, where are they? There. Okay? So what you want to do is you want to look at these answers that you get with the math, and you want to say, all right, if we use the negative value that we got, this would be a negative here. And that doesn't make sense, right? To end up with something less than what you started with when you started with 0. So you can reject the negative answer, okay? So either this answer is going to be negative, which is no good, or you might have an answer that's larger than the original concentration you started with, which would make this negative, which that's no good either. So the selected value here would be this value right here would be the value you'd use for x, okay? And then for the final concentrations, you're going to simply use that. So we got concentration of PCl5, I guess, was the first one. And that's going to be 0.25 minus this number. So let's do that. Let's do 0.25 minus 0.06284. And we have 0.18716. 0.18716. Concentration of PCl3 is then going to be the actual x value, and the concentration of Cl2 is as well the x value as well there, so 6284 or so. Okay, so these would be your solutions to this question. Yes, in moles per liter, that's right. We're not done yet. Moles per liter. Yeah, you gotta have your units. You're right. The teacher once told you that, right? Right. All right. Anything else we're missing? Or any other questions about that? So here's the question and the answer, and it looks like, oh, look at that. I was pre-prepared. Oh, is this the same answer? Sort of. 10628-ish. Okay. All right, so so Monday, remember we have rate law and KEQ quiz. Study up.